Okay, next let us consider example 3.5. So we are asked to write a general script that uses a for loop to compute the factorial of an arbitrary integer n. So this is a fun example because it gives us practice using for loops, accumulator variables, generalization, and always when you're trying to learn a new skill, it's nice to practice on a problem for which you know the answer. And so in this particular case, MATLAB has a built-in factorial function, so we'll be able to directly test the result of our script that we create against MATLAB's built-in function factorial to check for correctness. So excellent. Okay, and so if you need to recall what a factorial is, so remember 3 factorials, 3 times 2 times 1, or equivalently, you can write it as 1 times 2 times 3. So in terms of generalizing, so the factorial of n could be written as n times n minus 1 times n minus 2, all the way down to times 1. And factorials are typically designated with this capital Pi continuous product notation. Okay, so let's flip over to MATLAB and let's write our script. Okay, so here I am now over in MATLAB, and let's solve the problem. Let's write a script to compute the factorial of n. Okay, so I'm going to go ahead and create a new script. Okay, and so our script will compute the factorial of n. Okay, so now when I save this, okay, as was already suggested in the problem statement, MATLAB has a built-in function factorial. So I don't want to call this factorial. The reason being is it's never clear to me if I were to name this factorial and MATLAB has a built-in function factorial, if I call factorial from the command window, which one MATLAB will actually call. You know, which path does it search first? Does it search the path that the factorial functions in, or does it search my current directory first? It seems to vary widely, and so to try and avoid mistakes, so I will just call this maybe fact n. Okay, fact underscore n. Okay, excellent. So in terms of precondition, okay, n, the number we wish to compute the factorial of. Okay, and postcondition. So let's say n fact, the factorial of n. Okay, excellent. Okay, so if I'm going to calculate the factorial, I know I'll need an accumulator variable. Okay, and so when dealing with continuous products, typically we'll initialize our accumulator variables with the value of 0. So I'll initialize my accumulator. Okay, and so let's give it a creative name like accum, or since my postcondition is n fact, it could just be n fact is equal to 1. Okay, so now if we compute the factorial, okay, it would be 4. So I'll use an index variable of I. So for I is equal to, okay, so n factorial, or remember 3 factorial, I could write as 3 times 2 times 1, or equivalently 1 times 2 times 3. Okay, so in initializing my accumulator as 1, we could do this 2 ways, and let's do it 2 ways and see that we get the correct answer. Okay, so since 1 times 1 is just 1, I could start with an index of 2. Okay, so I could loop from 2 to n. And then what I want to do each iteration is I want to take the current value of n factorial, and I want to multiply it by I. Okay, so this is a variable assignment statement, and so remember, when I'm looking at a variable assignment, so thinking back to chapter 1, what MATLAB will first do is perform the calculation on the right-hand side of the equal sign. So MATLAB will first perform the operation of n factorial times I. Then it'll take the result of that calculation and assign it to the variable n fact. Okay, and essentially that's it. Okay. So remember, MATLAB has this built-in function factorial. Okay, and so how I can call it is just factorial. So if I want to compute the factorial of 3, well, that's just 3 times 2, it's 6. So if I compare that with my built-in, or the script I just wrote, so my precondition is n needs to be assigned the value of the number I want to compute the factorial of. So if n is 3, and now I perform or compute factorial, so this is fact n, okay, and the current value of n fact is 6, an exact match. Okay, so to facilitate comparing, let's type n fact here to display the value of n fact. Then let's also display the result of factorial of n. Okay. Cool. Okay. So if I want to compute the factorial then of 100, I could do n is 100. Fact n is, so the result of my script is this big number, which agrees perfectly with the result of factorial. Excellent. So the last note before we close up is when I set up my for loop, I started with a loop index of 2. Okay, and so what is going on here is I start or initialize my accumulator with the value of 1. Then when I come to my for loop, I is going to be initialized with the value of 2. It'll multiply the current value of n factorial, which is 1 times 2. All right, and so that's 1 times 2. Then it loops around. Next iteration, I is equal to 3. And so then n fact has a value of 2 assigned to it, which is essentially 1 times 2. Okay, and it'll keep building up my factorial. Okay, I started with an index of 2 because 1 times 1 is just 1. Right? And whenever we have a continuous product, almost always we initialize our accumulator variable as a value of 1 because anything times 1 is just that anything. Okay? Just like when we're computing sums, our accumulator variable almost always is initialized with the value of 0 because anything plus 0 is that anything. Okay? And so if I change that lower bound to 1 and rerun it, you'll see the answer is exactly the same. It doesn't make a difference whatsoever.